Hello students, welcome back to my channel. So we have been learning about network topologies. In the previous session, we have completed bus topology, ring topology, and star topologies. In today's session, we will see mesh topology as well as tree topology, right? So the very first one is a tree topology. So something like this we have already seen when it comes to the bus, isn't it? Where we had a communication line in between and then they are system connected. But it is a different variation to that. So a variation of bus topology is nothing but a tree topology. As you can see, it looks like a tree. The shape of the network is that of an inverted tree with the central root branching and sub-branching to the extremities of the network. So as you can see, it is in the bus, we directly had the nodes connected, but here we have another sub network which is connected to this main terminator. Okay, so that is your tree topology. So transmission in the tree topology takes place in the same way as in the bus topology. In both cases, there is no need to remove the packets from the medium because when a signal reaches the end of the medium, it is absorbed by the terminators. If you remember, when it comes to the ring topology, the sender was supposed to remove those packets from the network, wherein which in bus as well as tree topology, that itself will be absorbed by the terminators. Okay. So tree topology is best suited for applications which have hierarchical flow of data and control. So it is a data and control. Since the tree topology is a modification of a pure network topology, bus topology, it is a hybrid topology. So we can say that tree topology is a hybrid topology where we have used different kind of or we have made a variation to the existing topology. For example, bus, and then I'm adding a different network to the bus instead of adding directly to the node. That is why we will call it as the tree topology is also a hybrid topology. Next one is a graph topology. So this is a topology nodes are connected together in an arbitrary fashion. Okay, there is no exact pattern which we'll be following. We all know what is a graph. So here these are the nodes and this network connectivity will be like an edges to the node. All right. So that is why it is called as a graph topology. A link may or may not connect two or more nodes. Okay. So for example, these two nodes are not connected. It's not connected. If at all, if you want to send, it has to send through this system and then come here and then come here. So all the system need not be connected in any fashion. It can be, maybe, or may not be connected. There may be multiple links also. It is not necessary that all the nodes are connected, but if a path can be established in two nodes via one or more link is called as a connected graph. So here, for example, this is a connected graph because every node can be reached from some or the other link or the node. This is called as a connected graph. So this is how a graph topology looks like. All right. The last topology is a mesh topology. In this topology, each node is connected to more than one node to provide an alternative route in the case of a host is either down or a busy. Okay, for example, this system is connected to this, connected to this, connected to this as well as this. Suppose it is not connected to this. In that case, it has to go through this system, isn't it? So mesh topology is where we will try and connect as many nodes as possible. That is because suppose this system is not working. In that case, it is very difficult for me to reach this particular system. That is the reason we say that alternative route in case of a host is either down or too busy. So we will always keep an alternative route. For example, in the same situation, if at all, it has to communicate, then I can also use alternative route where I will come over here and I will use this particular connection. So it is an extension of P2P network. So point-to-point network we had seen in the previous session. So that is the extension of that point-to-point network. The mesh topology is excellent for long-distance networking because it provides extensive backup, rerouting, and pass-through capabilities. All right. So extensive backup, like I told you, if one of the node fails, still we will have a backup route through which we can do the sending of our packet, we can do the rerouting and pass through the capabilities. These are there in when it comes to the mesh topology. Communication is possible between any two nodes on the network, either directly or by passing through. Not necessary that I should have a direct. Okay, like a star topology, I need not have a direct connection to the hub. I can have alternate connection also. This function is needed in the event of a line or a node failure anywhere in the network. The mesh topology is commonly used in large internetworking environments with stars, rings, and buses attached to each node. So we can use all this topology together and form a mesh topology. It is also ideal for distributed network. What do you mean by distributed network? Is across, the geographically across, there are different nodes and there are networking supposed to happen. Then such networks are called as distributed network, and we will use mesh topology in such situations because locally I might be having a bus topology, and this bus topology may be connected to another star topology. Either star topology may be connected to another ring topology, and they may be connected to each other in a mesh topology way. So that is why we will say distributed networks. When in a network, each host is connected to other directly, that is, there is a direct link between each host, then the network is said to be fully connected. For example, if this is a host, this is a host, and I'm connected to this one, this is connected already to this one as well as this one. So here this is connected to, each one of the node is connected to each other, then it is called as a fully connected. So I have shown only 3 nodes here. There can be n number of nodes. If I have those many number of nodes, I will have those many number of links, and then that is called as a fully connected network. This character is termed as a full connectivity. Okay, so that is your mesh topology. So that's all. We have totally learned 5 topologies in this particular chapter. Total 5 topologies we have learned: bus topology, star topology, tree topology, mesh topology, and then we have also seen the ring topology. I hope these are clear. You need to know the working of it. You need to know the advantages and disadvantages, especially of bus, star, and ring topologies. All right. So that's all in today's session, students. Thank you for watching. Keep learning.